Assalamualaikum warahmatullahi wabarakatuh. Hi everyone. This is lecture 2 for topic 10, applications of differentiation. For this part, I will explain about subtopic 10.2, rate of change. Learning objective. At the end of the lesson, student will able to solve problem regarding rate of change, including related rates. dy dx is the rate of change of y with respect to x when we differentiate y is equal to fx. There are often, but not always, rate of change with respect to time. The rate of change of quantity q, dq over dt means the rate of change of q with respect to time t. Rate of increase is positive. Rate of decrease is negative. Rate of change of y and rate of change of x can be shown as dy over dt equals to dy over dx multiplied dx over dt, which we apply chain rule. We have 5 steps of strategies for solving related rate problems. The first one, draw a picture and assign letters to all quantities that vary with time. The second one, identify the rate of change that are known and the rate of change that is to be found. Find an equation, for example, area, volume, Pythagorean theorem, trigonometric ratio that relate variable. Differentiate both sides with respect to time. And finally, after differentiating both sides, substitute all known values and solve. Let's look at example 1. Gas is escaping from a spherical balloon at the rate of 2 cm³ per minute. How fast is the surface area shrinking when the radius is 12 cm? Alright, the information given in this question is the rate of 2 cm³ per minute. Centimeter cube is involving volume and minute is involving time, t. So then the rate of 2 cm³ per minute is dv over dt equals to -2. So -2, since gas is escaping from a spherical balloon, means that the rate of volume is decreased. Then when the radius is 12 cm, is r equals to 12. And the question asks to find how fast is the surface area shrinking. So means that ds over dt, since surface area is s, so then we are going to find ds over dt. So dv dt is actually dv dr multiplied by dt. So then volume of spherical balloon is actually 4 over 3 pi r cube. So then we can find dv over dr. So then dv dt is given in this question. So then dv dr we can find, and then for this part we can find dr over dt. And after that, ds dt is equal to ds over dr multiply dr over dt. So since we have surface area for sphere is 4 pi r square, so then we can find ds over dr. So dr dt we can find from dv over dt. So when v is equal to 4 over 3 pi r cube, so this is volume of sphere, which is dv over dr is equal to 4 pi r square. So then s equals to 4 pi r square. So this is surface area of sphere. So then we can find ds over dr is equal to 8 pi r. So after that, for dv dt is equal to dv over dr multiply dr dt, we can substitute dv dt is -2, and then we can substitute dv over dr, which is 4 pi r square. So then we get dr over dt is equal to -2 times 1 over 4 pi r square. So then we simplify, we get dr over dt is equal to -1 over 2 pi r square. After that, we substitute into the dsdt. We substitute the sdr is 8 pi r multiply the dt, which is -1 over 2 pi r square. So finally, the sdt is -4 over r. After that, when R equals to 12, we substitute into the SDT, we get negative 4 divided by 12, which is equal to negative 1 over 3. So the conclusion is, the surface area is shrinking at the rate of 1 over 3 centimeters square per minute. Let's look at for example 2. A container in the shape of hollow cone of semi-vertical angle 30 degrees is held with its vertex pointing downwards. You can see the cone is inverted cone. Water is poured into the cone at the rate of 5 cm³ per second. Find the rate at which the depth of water in the cone is increasing when this depth is 10 cm. Let the depth of the water is equal to H. Depth of water means kedalaman air is H. And then the radius of water surface is equal to R cm. Jejari pada permukaan air. So this is R. And then the semi-vertical angle is 30 degree. Then the information given in this question is dV dt equals to 5. So the rate of volume is positive since the water is poured. Water is increasing. Then we are going to find the rate of the depth of water in the cone when H equals to 10, which is we are going to find dH over dt when H equal to 10. Now, we are going to find dH over dt when H equals to 10. So, since the chain rule of dH dt is dH over dt equals to dV dt multiplied dH dV. So, then we can find dH dt since we have dV dt equals to 5. But we need to find dH over dV. So, dH over dV we can find from formula volume of the cone. So, the formula is equals to V equals to 1 over 3 pi r squared H. So, since we have two variables on the right side, so we cannot find dV over dH. So, then we must substitute R is in term of H. So, then we get V in term of H. So, from this diagram, we put out the right angle triangle. So, then we have this is right angle triangle with the angle is 30 here. So we can find from the relation of tangent. So then tangent 30 degree is equal to R over H. So then R equals to H tangent 30 degree. Since tangent 30 degree is 1 over sec 3, so finally we get R equals to H over sec 3. So this is R in terms of H. We can substitute into formula volume of the cone. So then we get volume in terms of H. So then volume is equal to 1 over 3 pi multiply H over sec 3 square multiplied by H. So finally we simplify the formula of volume. We get volume equals to 1 over 9 pi H cube. So this is volume in terms of H. So then we can find dV over dH. So we differentiate, we get dV over dH equals to 1 over 9 multiply 3 pi H squared. So then we simplify, we get dV over dH equals to pi H squared over 3. So then to find dH over dt is equal to dV dt multiply dH over dt. We substitute dV dt with 5 and then dH dV we can terbalikkan pi H squared over 3. So then dH over dV is 3 over pi H squared. So then dH dt is equal to 15 over pi H squared. To get dH dt when H equal to 0, when H equals to 10, so we substitute in H equal to 10 into dH dt. So then we get dH dt equals to 15 over pi 10 square, which is 3 over 20 pi centimeter cube per second. Let's see the example 3. The total cost of manufacturing P boxes of chocolate, a function of T, is given by C in term of P equals to 3P square plus 2P plus 300. where p in terms of t is 2t squared plus 75t. Compute the rate of change of the total cost with respect to time when t equals to 1. The question asks to find the rate of change of the total cost with respect to time, which is the total cost is represented by C. So then, rate of change of total cost with respect to time is dc over dt. To find dc over dt, the chain rule suppose dc over dt multiply dc over dp multiply dp over dt. So then, we need to find dc over dp and dp over dt. From C, in term of p equals to 3p squared plus 2p plus 300, we differentiate, we get dc over dp is 6p plus 2. So then, to get the value of dc dp, we must find p first. So, the information given in the question is t when t equals to 1. So then, when t equals to 1, p in term of t equals to 2t squared plus 75. So then we substitute t equals to 1, we get 2 plus 75. So p, we get 77. So then, when p equals to 77, dc over dp is 6 times 77 plus 2, which is equals to 464. While p in terms of t equals to 2t squared plus 75t, we can differentiate p in terms of t, we get dp over dt equals to 4t plus 75. So then, when t equals to 1, dp over dt is equal to 4 times 1 plus 75, which is equal to 79. So then, finally, dc over dt equals to dc over dp multiply dp over dt, which is 465 multiply 79. And we get dc over dt is 36,656. Now, let's look at for example 4. A 8-meter ladder rests against wall. You can see the figure below. Base of the wall is x. If the bottom of the ladder is sliding away from the base of the wall at the rate of 0.0 meter per second. So the tangga is sliding away from the base of wall. So means dx over dt is equal to 0.4. How far is the top of the ladder moving down the wall when the bottom of ladder is 2 meter from the base? So the top of ladder is y. So then the information given is dx dt equals to 0.4. Then we are going to find the bottom of the top. How far is the top of ladder when the bottom of ladder is 2 meter from the base? So x equals to 2 when we are going to find dy over dt. Okay, for the solution of example 4, so we have information dx dt equals to 0.4. We are going to find dy dt when x equals to 2. So first, by using the Pythagorean theorem, so we have x squared plus y squared equals to 8 squared. So this is from diagram. So then, let equation 1 equals to x squared plus y squared equals to 64. So then we differentiate 1 with respect to t. So we get 2x dx dt plus 2y dy dt equals to 0. So this is implicit differentiation. So then we get dy dt equals to negative 2x dx dt. So kita susun dia, kita pindahkan. So then we get dy dt equals to negative x over y dx dt. So then substitute x equals to 2 into equation 1. So we get 2 squared plus y squared equals to 64. So then y equals to 7.75. Substitute x equals to 2, y equals to 7.75 and dx dt equals to 0.4 into equation 2. dy dt equals to negative x over y dx dt. So then we get dy dt equals to 2 over negative 7.75 multiply 0.4. So then we get negative 0.4 103. Since dt is less than 0, we conclude that the top of the ladder is sliding down the wall at the rate of 0.103 meter per second. Now let's move to example 5. Water is poured into an inverted cone of height 12 cm and radius 6 cm at a rate of 10 cm cube per second. Find the rate of change of the height of the water when the height is 5 cm. First, we draw the inverted cone. Then the water is poured. We have height of the cone is 12 centimeter, and then we have a radius of the cone is 6 centimeter, and let H equals to height of the water. So water is poured into cone, so then H is height of the water, ketinggian air. So then R is the radius of water surface, radius untuk permukaan air. Then the information we have 10 cm cube per second. This is volume dV, volume in term of time, dV dt equals to 10. Since the water is poured, so the dV dt is increase, means that is positive. So then we have the height is 5 centimeter, so H equals to 5, and the question asks to find the rate of change of the height of the water, which is dH over dt. So then the chain rule of dH dt is dH dt equals to dV over dt multiply dH over dV. So then we need to find dH over dV to get dH over dt. So from the diagram, we can put out the right angle triangle. We have volume equals to 1 over 3 pi r square h. So then the diagram, we have two triangle. We have a pink triangle and yellow triangle. Okay. So then since we are going to find dH over dV, so we can find dV over dH from V is in term of H. So since we have two variable on the right side, so then we need to substitute R in term of H. So then to get R in term of H, we can using a ratio perkadaran untuk dua triangle yang warna kuning dan warna pink. So then R over H is equal to 6 over 12. So jadi kita compare. So then we get R equals to H over 2. So then we substitute into V. R equals to H over 2 into V. So then we get 1 over 3 pi multiply H over 2 square multiplied by H. So finally we get volume in the simplified form is 1 over 12 pi H cube. So then we can differentiate V in term of H. We get dV over dH equals to 1 over 12 pi multiply 3H squared. So dV over dH is 1 over 4 pi H squared. After that, we substitute into dH over dt. Then we get dV over dt multiply dH over dV. dV over dt is 5. dH over dV we can split dV over, we can terbalikkan dia. Since dV over dH is pi H square over 4. So jadi kita terbalikkan dia, we get 4 over pi H square. So then kita substitute value H equals to 5. So then we get dH over dV equals to 4 over 25 pi. So then dH dt equals to 10 times 4 over 25 pi. So finally we get dH dt equals to 8 over 5 pi. So as a conclusion, the rate of change of height of the water is 8 over 5 pi centimeter per second. So this is the end of lecture 2. That's all for now. Thank you. Assalamualaikum.